Today we've got Joshua Neal joining us. Um, I will let him do kind of a full intro, but Joshua has a really, really unique experience, and both from a work as well as in the academia. And he's going to be talking about anomaly detection. So that should be a super interesting topic because I feel like it's sort of one of those things that's pretty cornerstone to cyber defense. So on that, Joshua, do you want to introduce yourself?
Yeah, thanks, Maxim, and great to be on the call today. I was looking forward to this, both to talk to a lot of people, great people, but also have a good interaction and maybe learn some things too. Um, so, uh, if you wouldn't mind, I'm going to stand on a pedestal for about 5 minutes, and I'm going to introduce myself, but it also introduces the topic of anomaly detection. So, my favorite subject, myself, I'm gonna spend about 5 minutes on that, and then we'll open it up. Um,
Beauty.
so let's see. So yeah, I've been in research and product development for 25 years, all in cybersecurity. I started at Los Alamos National Laboratory in 2000. Los Alamos is a U.S. Department of Energy lab. It's a national security lab. They do all kinds of research. You might know of them from the Manhattan Project, but they are a national security laboratory. It's not just nuclear research. Hey, Corey, uh, and uh, it's a great place to work. It's really neat and because it's quite academic,
Are we good with this one?
I think we need to do some muting. Um, because it's a academic institution, but also, really geared towards national security. We worked on really hard problems and we worked on really open problems because we're really research oriented and we had really important stuff to protect. And so I was lucky enough to be this weird statistician. Machine learning was pretty new in 2000. It was kind of like, wow, that's weird. But I was really on the ground floor of applying machine learning to threat detection in enterprises. And I think I was just very fortunate. Um, sort of accelerating. We did a whole lot of stuff at Los Alamos, but one of the things we really leaned into was anomaly detection. And in 2014, well, in 2011, I published my dissertation on the subject of anomaly detection for lateral movement. And that led to a product that sort of surprised us that got a lot of adoption in the government and then was licensed to Ernst & Young in 2014. And so in 2014, I moved over to EY to build a product team and a sales team, and we took that thing on the road. And my experience at EY was anomaly detection has this great advantage of finding threats that you can't find any other way. And that's because anomaly detection is actually about modeling normal behavior. I want to be very specific about what I mean by an anomaly. An anomaly is a rare event. It's rare. If you go and look at the dictionary, that's the definition. It's a rare event. Okay. Well, you can't really know what's rare unless you know what's normal, right? So a lot of hey, Stephanie, nice to see you. A lot of what it goes into anomaly detection is encoding into models what to expect. That's the bulk of the work there. It's not to find the bad guys, it's actually to understand and encode normal behavior. And then deviations from that normal behavior are what you call anomalies. And so, because of the low or basically no assumptions about what an attack looks like, when we would deploy this tool, PathScan, into a prospective customer, we would find stuff that none of the rest of their tools found. And as soon as we found something that was bad, we'd make a sale. Because I tell you what, if you show a CISO a threat that they didn't know about, that none of the rest of their tools knew about, they're going to buy your product, and it's kind of like how much at that point. Great. Okay, we're on a roll. We're doing great. And my dream is being realized. I have a starry-eyed researcher amazed that anything my research did was actually interesting and on this crazy journey with EY. But then I'd come back a couple of months later and I'd talk to the SOC and they said, yeah, we can't handle it. There's too many alerts. It's finding everything. And I learned a very hard lesson as a younger researcher of the intersection between rarity and maliciousness is very small. A lot of things are rare in an enterprise. Only a small, tiny amount of those are malicious.
Yeah,
And
just
that
to put some numbers on it, right? Let's say you only mark 0.1% of events as anomalous, and maybe they truly are anomalous for your organization, but there's a long tail of anomalous but non-malicious. So it might
yeah,
be 0.001% that's
yeah,
actually malicious. That means
yeah,
that for every 100 alerts or 1,000 alerts analysts see, only one is actually malicious.
right.
And we can quibble about the percentage, but if your SOC sees 100 known or marked as malicious events for one actually malicious event, humans being humans, they're not going to internally believe that it's malicious until proven otherwise at some point.
They're going to
If
start
the false
ignoring.
positive rate is high enough, humans will stop caring. It's the TSA problem, frankly.
Yeah. And then the net result of that is you're missing bad guys anyway. Now you're immune, you've become immune to the real threats because you're buried by false positives. And there's lots of other repercussions, labor and things, but the real human cost is they just start ignoring your stuff, right? They just ignore it.
You mentioned the rare part. I'm kind of curious. Do you think it's rare? Is part of the problem that something is rare at the scope of a single company? But if you were to say, hey, if I increase my scope to, something silly, like half the companies, worldwide, now this thing's not rare anymore? Or is it truly
Yeah.
that even regardless of the scope, you're still going to end up with those minute
Yeah,
rare
it's
cases?
that second one, and we tended to go very fine in our precision. So we would model every user and every process and every network communication, every pair of communicating computers, right? And so at very fine resolution, you still get rare events all day long because what you're doing is you're putting 100,000 humans under very careful monitoring, and those humans go do weird stuff all day long. One of them, not in aggregate, one of them's going to do something weird every minute of every day. That's kind of the basic thing. And so that was painful. I thought it was going to change the world. Nope, you haven't gone far enough. But I never left. I could not get out of my heart and soul the promise. When you find an attack that nobody else knows about, it's sexy, right? There's a piece of gold there. And if we look at the industry and we're still missing breaches, well, there's still opportunity there to find the threats that rule-based detection is not finding. There's still something there, and I couldn't let go of it. So I moved on. In 2018, I joined Microsoft. I led the Defender for Microsoft Defender for Endpoint, which at that time was called Windows Defender ATP. I led their data science team for several years. We also incubated their XDR, which is, I can't even, I think it's M365 Defender at this point or something. They keep changing the names. Um,
Microsoft 365 for Defender, ATP Defender
ADP, yeah,
365
This
Windows,
week.
I think.
requires E5.
Yeah. And uh, I got to work a lot more with alerts and the creation of alerts in lots of different ways. And then with XDR, sort of the alert combinations and things. And then I moved to Secure Onyx and I was the chief data scientist there. And I got to see what a SIM looks like and what your average SIM customer is dealing with and an analyst is dealing with on a daily basis, which is no fault of Secure Onyx. Okay, I don't want to sort of target Secure Onyx here. I think this is broadly true, is that analysts today are dealing with a lot of garbage. And I hope that's not salacious, that your average customer and your average security team is dealing with a lot of noise and very little signal. And it was sort of shocking to me that threat detection has not moved very far beyond what it's been doing for 20 years. And there's just a lot of garbage and noise. And during these time with Defender and Securonics, I also started to develop ways to unlock anomaly detection. What you got to do is limit the false positives because it already has the value of being able to find the threats you can't find any other way. That's great. But you got to go tackle that false positive problem of anomaly detection.
And I
And
think there's the underlying assumption that the malicious behavior is itself anomalous, which is not necessarily the case with many modern breaches taking advantage of features from start to finish as well. Like false negatives will always be a thing. This can find some attacks that will not be found kind of by definition by your normal operations, by your normal alerts. However, there are intrinsic false negatives to anomaly detection if the attacker is doing things that are normal for your environment, such as making backups, right? If I'm the attacker that's making backups online, that's also known as data exfiltration.
um, I think I would say with the right context, those things will stand out as malicious. And I don't think using just anomaly detection to find that context is the right thing. In fact, what I've seen a lot is that people either build anomaly detectors, pure model-based anomaly detection, or they build rules, but they don't combine them together. And that's really the thesis of Alpha Level, is with the right context, both from alerts and alerts are they're precise. They, with an alert, you encode the attack behavior, right? So you have an exploit or you get some threat intelligence and you write a rule to go search for that. That is encoding the enemy, okay? Anomaly detection, I made this point earlier. Anomaly detection is really about understanding the normal and encoding the self. And a thing that vendors are challenged with, and I think even detection engineering teams within enterprises are challenged with, is all the edge cases of an enterprise that are normal. They're normal, benign stuff that a vendor with a rule-based portfolio of threat detectors can never scale and capture those normal events in any one enterprise that they're selling to because they would have to constantly write rules for every enterprise. They can't scale that. And even detection engineers with static rule-based detectors can't encode the exceptions in a constant and dynamic way. Now you have this giant maintenance problem. You've got to constantly add and remove rules to actually cover the false positives, to remove the stuff that you know is fine for this enterprise, but is not fine for some other enterprise. And
I'm
so,
curious, Josh, real quick, how do you think
yeah.
teams figure out what's fine?
Um, you you know what I do is statistical modeling and machine learning. That's an automated approach to encoding what's fine, right? And so that's where I'm at. I think a lot
But
of
even before that though, like how do you even know what to
yeah,
feed the model? Like, is there documentation magically that you read? I think I'm kind of like burying the lead here. Like, I think the reason rule-based detections from vendors don't work is because vendors don't know your environment. The
yeah,
reason that these teams hit a ceiling is because the engineering cost, one, the documentation is not present, the knowledge is not present, or it's not documented. So they don't even know what normal is. That was
yeah,
certainly my experience. They have no way to know what normal is. And so you
yeah,
just you wing it, right? And then a lot of these teams also don't have the engineering muscle or the staffing, whatever it is, the support to be able to say, okay, I'm going to make a strategic investment in figuring out what normal is because now I've got a requirement on my technology teams, whether that's software engineers or IT teams, to come and sit down at the table and say, well, here's what we thought we built. Here's how we thought it was supposed to behave. And here are maybe the things you can look at. Instead, you sort of have what I see as a very like hands-off view of the world in a lot of teams, both incident response and threat detection, which is like, I can't understand this system. I'm like a victim of the things that are happening to me. Maybe that's an overly pessimistic attitude, but I think there's actually an organizational gap that no amount of technology is going to solve, and domain specificity to your organization that I think is really at the core of at least maybe the more medium to advanced teams. Why can't they get that next little bit? It's because they have no baseline on what normal is, and they spend all their day listening to some vendor tell them, I thought I saw something unusual. It's never unusual. It's just noise. At least that's my, I wonder if you have a similar viewpoint or if other folks have seen that.
Yeah, I do. And boiling the ocean, well, I can't boil the ocean, and so I can't, I wouldn't claim that I would encode everything I could possibly do about an enterprise as normal behavior. You know, I could take I could get down to the bits happening in the operating system and the registries and the bits on the wire. And, you know, at one point I was ambitious enough to think that I could establish modeling for every possible thing you could do. And that's just not realistic. So what I do is pick and choose. And, you know, there's some obvious things to model to encode normal that aren't going to boil the ocean, but are going to get an 80-20 sort of encoding of what should be expected. And these are things like authentication, um, process behavior, you know, certain elements of endpoints and authentication behavior, and then network and how machines and entities are relating to each other so that you can find flow of an attack. And I'm not modeling a whole bunch of other stuff, right, that I could, but is sort of diminishing returns on understanding what's normal.
Let me ask you a for example that in a past life, I don't want to be too specific, we saw, which was way more basic than what you're talking about. There's a Slack channel centered around cloud operations that was pretty much filled all day with security engineers asking cloud engineers, is that service supposed to run there? Is that port supposed to be open?
Yeah.
Is that service supposed to run on that IP? Is that service supposed to send that much traffic? How are you approaching these very basic problems of like, I just deployed something and I can't even know if it was supposed to be deployed?
Yeah. I'm a data guy. So my approach to that is collect what is happening now and then look for deviation from what has been established just in evidence from the enterprise. I am not saying this is what should happen. What I'm saying is this is what I'm seeing, and I'm going to build models based on what I'm seeing already and look for deviation from that. So that puts me in a certain bucket. That isn't the whole thing. It is just use the existing behaviors in the enterprise to encode models and then look for deviations from what I have learned is normal. And in that way, I can scale. If I can deploy self-learning models that update and forget old behavior and learn new behavior, and I can do that in the right sorts of ways, then I'm not saying anything about what should happen.
Yeah.
I am only saying this is not what I'm expecting given what I've seen in the past.
Yeah. I think my last comment on this would be, and I don't want to say never say never. Someone told me that once. Anyway, I rarely, as a person I've done a lot of things, but AppSec is kind of where my biases lie. I almost never hear defenders who ironically are almost never AppSec, which is another funny thing. But anyway, threat detection teams are rarely looking to the AppSec team who is actually sitting on top of all the changes that are happening and establishing some kind of information sharing to say like, hey, we saw them design this thing and it had these attributes. And how can we start to feed that to something we thought about quite a bit? We didn't solve it, but like there's something I rarely hear talked about. Like, why isn't AppSec a primary data source into threat detection? Because if you wanted a source of information about what we thought we built versus what was actually deployed, I think one of the main opportunities is there, and I almost never sort of see tightly coupled AppSec and threat detection teams.
Well, you just taught me something. Thank you, Jacob.
Yeah, it's interesting. I think that applies really well to product companies.
That's a great point.
Yeah. So as a product company, I think that's super interesting.
Yeah.
What I would kind of like throw a thought in there. I'm curious if Joshua or Jacob like have thought about it or looked at it that way, but it feels like the thing that's missing between maybe those two worlds is kind of the idea of like how nowadays, like, sorry, I think about like it from coming from like the AI things these days and RAG search, like semantic searching. And it feels like maybe what's missing is the ability to do like a semantic search or characterization of a situation after after an anomaly was detected, right? Like, hey, this thing was detected. Now maybe it's just a user doing something weird, but being able to do a semantic search through like the sim to say, hey, okay, but like help me understand the context here of like this was done by sysadmin. Okay, but this was done by sysadmin and they're working on this thing, and the port that they opened up is to like a private, a VPC that is completely closed to the world, and they're deploying hundreds of things there every day. Like, oh, this feels like a developer and this might be fine, right? So it's like this very human LLM type evaluation that feels like it
Yeah.
would be interesting.
You know, I want to take it one level up from LLMs or semantic search to maybe capture what Jacob said and what you just said and what I'm thinking too, which is right now we're encoding what we don't want to see. We're encoding the adversary. Rules encode the threat. Um, if we can also encode what should happen, either what's normal and deviation from normal, which is what anomaly detection does, or what Jacob suggests is, I developed an app. I know the constraints upon which I want to allow this app to operate. I know what's good. I probably also know what I don't want the app to do, right? You're you're getting both sides of the coin. You're encoding what the enemy is doing, and you're encoding what you should be allowed to do. And so that's sort of stepping up to the
Yeah.
level of can we include what we expect and what is normal in our calculations of whether we have a threat or not? Because today all we're doing is encoding whether it's a threat or not, but
Yeah.
not is it like what is it allowed? Should we
Yeah.
let that happen?
And this is what we found is that at a certain scale, there's a tipping point where now, and when you hear the sort of endless, too many false positives, too much noise, whatever, it is because you have to take all these exotic methods to do a first pass filter to say what's noise. And to us, one of the things we saw was just that nobody knows what's supposed to happen. And at a certain size, everything everyone does looks anomalous because the activities are so varied. And so like, how can we have something where we just say automatically reject all of these things because I saw that PR, I saw that review, I know that's supposed to happen. So don't tell me about that thing.
I gotta tap the side and say you can never know what unusual is until you know what normal is. You can see events that are rare inside your environment, but that does not mean that they're not normal. It's just that they might be rare. They might be quarterly or monthly events. You cannot know what unusual is until you know what normal is. Baselining has to be a thing. It essentially has to involve humans talking to humans, aka the hard part. You're never going to work your way around that fundamental problem, just like we're never going to install enough EDRs to make it so we don't have to patch.
Yeah, I agree. I
Joshua,
agree. And
sorry,
this
I was
is
just curious.
actually, oh, sorry, Ken, go ahead, please.
Oh, I mean, we talked a lot about this, like about baselining behavior, right? And I'm kind of curious, like what we talk a lot about, AI and things, and everyone thinks about LLMs, but it seems like things like unsupervised machine learning, which were pretty heavily used for kind of baselining behavior, right? Is that primarily what you use to baseline what's normal in an environment?
Absolutely. So, and in particular, I focus on time dynamics, and I'm a statistician, so I model dynamics in time a lot, and we're really good at stochastic processes and modeling of time and the correlations and relationships between events and things like that in time, in dynamics there. I will say on the LLM subject, and it's maybe controversial, I don't care. I think these methods are too imprecise for threat detection, where precision and recall, being very surgical in what you expose to a SOC, is the name of the game. Now, once you get beyond the initial emergence of the threat, which requires surgery, okay, summarization and bringing stuff together and telling a natural language story, great. Let's use natural language processing, generative AI for that. But I'm not going to use it to find the bad guy in the first place. I think we're already struggling to do that well, and taking an LLM and trying to do that is just adding a bunch of noise, in my opinion. Now,
Look, I could not violently agree more with you. This to me is I got a research paper being written right now on like, don't use LLMs to reason. Like NLP is great. Understand natural language with the state of the art in natural language understanding. Stop trying to accidentally reason with a model that might accidentally happen to encode some of your domain reasoning. Makes no sense to me. I won't go too far, but like instead, use it to extract the information you need to build the reasoning model you need. It'll be great at that, and it's going to 10x your productivity there because you can not have an engineer reading and summarizing all day.
Yeah, agreed. I've fought this fight too long to think a brute force method would come and solve it.
If there's an area of your work that you don't mind very subtle mistakes being introduced, and it's really easy to catch those subtle mistakes and fix them later, then that's a good spot for AI. Sure.
Yeah. And I think actually
most places for most decisions, that's not a great situation, though.
I think in threat detection, which is a very precise game, it's not the right place. But I also think these LLM AI assistants, or whatever you call them, are going to benefit from better signals coming into them in summarization and contextualization. So this is augmentative. I'm not eliminating LLMs from security. I'm saying they better have good data coming into them. And that's what we're talking about today, is before it gets to the LLM, in my opinion.
So it seems like LLMs might be good for helping us know what questions to ask, whereas other elements like machine learning, like unsupervised, supervised machine learning, are more precise, right? So
yeah.
Kind of another question too. I mean, it seems like a lot of data science, like really, it's like I took a few courses and most of it was like data sanitation. like 90% was just getting the data, in such a clean state that the models can be utilized. So I think that's one challenge. I think for security in particular is how do you ensure that you have the right data and that it's clean enough and to kind of train those models.
Yeah, I started out as a statistician. Right. What I didn't realize is that most of my career would be spent in first getting the data. And you can imagine in 2000, right? We didn't have even endpoint agents deployed, right? We had very little visibility inside the enterprise. We could see perimeter crossing. And then, we started to get visibility. But then we had a storage and compute problem, which Lima Charlie is. I'm going to get a little pitch for Lima Charlie, but them and others are finally starting to solve, so that I can actually go back to being a statistician. Thank you very much. I don't need to worry about map reduce. I don't need to worry about. I do still need to clean data, and every customer I go to, I've got to help them improve their data quality. That's just a burden of the industry. I think we're all going to fight that. But I think the infrastructure revolution, I believe, is happening now, and it's unlocking people like me. I was wondering if I would be dead before the industry got its act together to actually do the thing I want to do. Yeah, I didn't even, but I think
Awesome.
we're actually there, and I'm not dead yet. So.
And on that positive note, which that's a great way to end, we're pretty much at time. Thank you so much, Joshua, for coming in. That was super interesting. Thanks for everybody that came, listened, participated in discussion. We will see you next week. If you want to go and join keep the discussion going, we have our Slack community, slack.limacharlie.io. And we will see you next week. Thank you.
Thanks.